Hello and welcome to the Arkansas GIS Users Forum Educational Webinar Series Plus Training. In this episode, we take a classroom approach with the Introduction to Python in ArcGIS Pro, instructed and presented by Robert Kacir.
All right, so first thing we're going to do is we are going to tackle Hello World and data types. So why don't we start off with what exactly is Python? I'm going to launch this poll from the interface, and as we go through this unit, I would like you to fill it out just as we're going. So first question, what exactly is Python? What do you think it is? Is it a full programming language? Is it some kind of text formatting for ArcGIS? Is it really just the same thing as Arcade? So go ahead and fill that one question in. All right. So what Oxford kind of defines it as a high-level general-purpose programming language, and that's kind of a simplified definition. But really, what that kind of says is that it's not close to the metal. So there are many programming languages out there that what they say is close to the metal is you actually individually change, assign specific parts of memory to different things and actively manage that, and you really have a fine level of control that involves a lot of code. Whereas Python is a very much more generalized, higher level language, so you don't have to put in nearly as many lines of code to get something done. But and also it's not specific to a specific type of program. So there are tons of Python applications that are outside of the ArcGIS universe. So you guys have probably used a purpose-specific language before. If you've heard of R for statistical use, that's fairly narrow. Similarly, you probably have, everyone here has used Excel before. That is actually something called DAX, and that is very, very specific to Excel in its format. You really can't use it much outside of that. So there are a few out there, and some I'm sure you guys have heard of C++ and C, and so those are languages that involve changing individual bits of memory and managing that, and Python just completely circumvents that. You don't have to do it. So Wikipedia, I know you guys can read that. There's a little bit more in there, but I suppose some of the key things in there is that it's object-oriented. And another thing, too, that makes it very different from other languages is the use or the lack thereof of curly brackets. And I think you'll appreciate this even without necessarily knowing much about the language to begin with. So most the majority of programming languages out there that are in common use curly brackets to help define different blocks of codes and groups of code, whereas Python uses tabs. And you'll see this in a minute, what kind of difference it makes in how trying to understand things. So there's another thing too here. So I mentioned object-oriented programming. So there's really two different major styles of programming, and it varies. Your language may or may not support it. So you have procedural that is very straightforward. It involves functions. It's very linear. And it generally predates object-oriented. Whereas object-oriented programming is something that is much newer, involves a lot of abstraction, that makes it a little bit harder to understand, but the majority of the commonly used modern languages are object-oriented. So when it comes to ArcGIS, the majority of stuff when you're beginning out will all be in procedural style coding. But since Python supports both, you'll find that there's a lot of functionality that you actually need to use Python objects for. You won't be able to avoid it. We're not really going to go over object-oriented programming here. That's beyond scope. But what we can do is we can sort of talk about how to interact with objects, because even though we don't need to write them and modify them, we deep inside, like definitions, we can instead just interact with them without necessarily understanding how their inner workings are, sort of like a bit of a black box. So common functionality that you need to know object-oriented for. If you ever really want to write your own Python geoprocessing toolboxes, you're really going to need to pick up object-oriented. Similarly, Python add-ins. I know that Pro doesn't have these right now, but I imagine they're probably on the horizon. If you need to develop add-ons for ArcMap, it is a requirement. Additionally, if you get really deep into it and your code gets very big, you're going to want to use external modules. And so it's something that I'd recommend you guys be aware of, but we will not be covering that very in depth. So here's kind of an example of the curly brackets. So we can kind of see here that that a bunch of these pieces are kind of broken out into different groupings, and it's divided out by these curly brackets. But though the spacing they all put in, that is all put across here, is only convention. So this could be a jumbled mess, and you have to sort through where all of the curly brackets are and how to divide it out. Whereas Python really doesn't have those curly brackets, so you can kind of tell, hey, this is a group of code that probably goes together. This is a group. Oh, maybe that. And so it generally encourages you to organize things better. And it's generally a little bit easier to pick up. So what I'd like to do with you guys is go ahead and launch ArcGIS Pro, and we are going to make our first line of code. All right, I'm going to do this with you. All right, can everyone see my ArcGIS Pro document okay? Can you give me a thumbs up? Perfect. All right, so what I would like you to do is go ahead and open up ArcMap, and we're going to go into View, Python window. And we're going to want to make sure that's nice and open. And then we're going to put in our very first line here. And so it's going to be print in all lowercase, followed by begin parentheses, then a double quote, hello world, another double quote, and then a finishing parentheses here. And once you're done with typing, you're going to hit enter, and you should see a message printed below it saying whatever you put inside these double quotes. All right, so I'm going to give you guys a sec to finish that up. When you're, if you got that to succeed, give me a thumbs up. If you did not get it to work, how about you give me a no icon? Okay. So one thing with the code is it has to be typed exactly. So if you have anything that is the wrong case for print, that can cause you to have an error. So let's say if I go print, and you'll notice I get an error message here. All right, did that solve anyone's problems? All right, perfect. So did everyone manage to get Hello World to work? Could you give me a thumbs up? All right. So that was your very first line of code. And it print will be your friend and your enemy moving forward, trying to learn some of this stuff. But it's very good for debugging things when you're initially starting out. All right. So we had our first line of code. Now let's kind of break down what exactly that is. All right, so if you guys didn't get that first line, maybe look really closely at this, and then I can actually post this into the chat if you guys get stuck. So you have the first line, so your print here is what is called a function. So a function kind of does some sort of action. And in this case, all of the action is it creates, it prints something to your command line or whatever your interpreter is. And so any function in Python will all follow this convention. We have the function name followed by, oh, yep, that would help if it was hello world and not hello word. Thank you. Yeah, so print, you have the parentheses on both sides. Again, it's type sensitive for that, for cap sensitive for the function name. And then we also have a number of different parameters and go in the function. And so this double quotes here is a single parameter to the print function. And we can actually change this print text that goes in here so they can print off something different. And so I'm sure many of you have probably already tried this, but how about changing out some of that stuff so it no longer says hello world, it says hello world, or says hello ArcGIS users forum? I'll give you guys a good minute. And go ahead and just play around with that, see if you can get it to crash or anything. All right, it's been about a minute. So as far as it goes with hello world, or for any of that matter, we just have to make sure it's contained inside of these double quotes. And so we can say Arkansas GIS. And just you can modify that accordingly to change out whatever's in the double quotes. Yeah, change the hello. All right, is everyone good with modifying hello world? Could you give me a thumbs up? All right. Is anyone not okay with hello world? All right. So some of you have probably experienced errors with your first line of code. And there's a couple different types of errors that we encounter when we're writing stuff. And so it's kind of nice to know the difference, because that kind of dictates how difficult it may be to fix, as well as how it you might want to just solve it. So the errors that you most likely have seen already are syntax errors. So you remember when I printed something, use a capital P on print? That is called a syntax error. And so when you change things, let's say reference functions that don't exist, or you just arrange the code in a way where it won't even compile, it won't even run, that's when you have a syntax error. And similarly, then you have there's two other types of errors which you haven't quite seen yet. So you have runtime errors, meaning that when you initially started the program, it did begin to run, but somewhere in the lines of code, it said, "Nah, I'm going to crash." And it crashes on a particular line rather than on the entire script. And then we have semantic errors. And semantic is the type of error that you will see at the very end of your coding process. And it's also the hardest thing to fix. So semantic errors involve there being nothing wrong with the underlying code when it runs. There's no syntax errors. It doesn't crash when it runs, but it perhaps, does something you didn't want it to do. It gave you a result you didn't want. So if you had it multiply 5 times 5, and then you got 100, that is not the answer you were looking for. That would be a type of semantic error. So a little bit of a pop quiz with our poll as far as with syntax errors and what types of errors fall under what. I'll give you guys a sec to complete that. All right. Let's go ahead and move on. So here's the basics of the basics. In Python, we have a number of different data types. And there's a lot more out there than what we're going to learn here. But frankly, there aren't that many that you'll need to necessarily know to get some utility for doing things in ArcGIS. And so we have strings, which I think you've already dealt with. You have integers and floats. Then you have lists. If anyone has experience with another programming language, you probably are familiar with arrays. It's very similar to that, except a lot more flexible, which apparently is offensive to really professional programmers, software engineers. It's not something they like. And then we have the dreaded Noun Type. And so if you are learning or just simply trying to debug something, the Noun Type might sneak up on you and come out of nowhere and being like, what are you doing here? All right, so there's more a subjective poll answer here, but what do you think would be, oh, I don't think we have a poll for this one. No, we do. Number 4. No, not number 4. All right, this one isn't here. All right, well, so first data type here that we're, one that you've already dealt with is the string. So notice that hello world was put into these double quotes here. Anything in these double quotes is considered a string, and they can carry pretty much any type of text. So you'll see like alphanumeric characters, so A through Z, 0 through 9, and so on. But then things get really weird. ArcGIS Pro is using Python 3, and from Python 2 is what ArcMap was running on. One major change between the two is Unicode characters. So how many of you guys have used emojis before? Give me a thumbs up. All right, perfect. So an emoji is a type of Unicode character. And Unicode contains, is kind of a bit of a standard that goes beyond simply like A through Z, 0 through 9. Emoji covers hundreds of human languages. And so you have a lot of interesting things that can creep into it. Python 3 supports Unicode, and so if you're, let's say, I'm not sure how many of you guys have pulled in a spreadsheet into ArcMap that was originally in Excel. And I think you will find that interesting Unicode characters will pop into it that you didn't know what they were. And so that's just something to keep in mind, especially since although Python supports Unicode, ArcMap does not. ArcGIS Pro doesn't support the entirety of Unicode. So you may end up experiencing some weird things there. That's a little bit of a tangent. I've had some really, really weird stuff show up through those spreadsheets, and it's all due to Unicode. So strings can be expressed two different ways. You can use double quotes, or do you use single quotes? Either one works, and it really doesn't matter. It's pretty much a style choice. There's no functional difference. And strings are really, really important because in ArcGIS Pro and ArcGIS environments, if you're ever trying to pass the path to a shapefile or a folder to save, export, or read something from, you're going to be storing it in a string. We'll be talking a little bit later about some of the particularities that will kind of cause problems, but that is kind of the value of that. Additionally, if you have things like geoprocessing settings, the vast majority of those will actually be strings. And similarly, if you're ever going to read anything coming out of a table or a shapefile, anything that is text is going to be stored as a string, or at least that's the way you're going to be accessing it. So, perhaps I didn't mention this, but there is another function. We saw the print function. Now there is a type function as well. And so type is something that I find very useful when I'm pulling code together and it's giving me weird results, and I'll test it somewhere along the way to be like, is this the type that I was expecting? And sometimes it isn't. Sometimes it surprises me. I didn't know that existed. So, and another thing too is class can kind of be interchangeably used with type. It's not exactly the same thing, but I think for our purpose here, it'll be the same. So what I'd like you to do is go ahead and take the hello world text that we took from that first exercise. And I want you to go into Pro and run the type function on it. And you should be able to get the same result that I'm getting here. So if we open up Pro, type in type. All right. Give you guys a sec to try that out yourselves in your own code window. All right. Okay, I can see one person got it. If you give me a thumbs up if you managed to get that to work, to get your type function. Perfect. Anyone else? Anyone else not get the type function to work? Give me a no. All right. That seems pretty good there. So we have our type function, and you can change that out to just about any string you want, and it will be the same for most things. And then we've also got some two types here that are relating to numbers. So if you have any numbers that are in a shapefile, they'll usually one of these two types. There are more number types than this, but most of the time you only need these two. You have integers. Well, and there's more than one type of integer, but the vast majority of the time you'll be dealing with short integers. You don't have to worry about other types. And so integers are kind of a little bit self-explanatory. They're the same as you'd see in other programming languages. So you have a short integer, and it only contains whole numbers. It can contain negative numbers as well as positive numbers, but it really can't do decimal places. So why don't we go ahead and go through a couple examples here with our type function and see if it all shows the same type. We go ahead and open up our handy dandy Python window here. I'm going to go ahead and go in and say type. So let's say enter 5. We get int. We can choose some ridiculous negative number here, and that's still an int. We didn't even choose a large positive number, and that should be an int as well. Give me a thumbs up if you're managing to run the type function over your int. Okay. All right. That's looking good. Thank you very much. So again, a very useful type here, which you're going to see a lot of. And so those are your whole numbers. And then the other type we're going to see a lot of are floats. So one thing to keep in mind, and we're looking at numbers like both integers and floats, is that they do not correspond at all with the data types that ArcMap uses. So if you ever, let's say, adding a field and you're looking at a double or an int, they do not act the same. You can dive into the documentation, get into some of the details, but if you see a float in Python and then are looking at a field, maybe you pulled it from, don't assume they have the same characteristics. So basically floats, those are your things with your decimal places. So you can have however many decimal places you want, and it still acts as a float. So why don't we go through some examples with floats in our Python window. So if we pop over here and we put in type, let's put in a very small number. We see we get a float. And I encourage you guys to follow along with this as well. You know, we can even try a negative decimal number here. We can even get a large number, and that will come out to a float as well. So go ahead and I'd recommend entering in and trying out these three numbers here. And you should be able to see that they are all considered floats according to the type function. All right, so give me a thumbs up if you've managed to get your float code to work. All right, could anyone give me a no if you did not manage to get your float code to work? Okay, I guess we're doing pretty good today. All right, so here is a bit of a interesting type and one that Python as a language leans on very, very heavily. So I think I mentioned earlier that lists are kind of akin to arrays in other languages. And so they act as containers. And and these things can contain close to infinite number of items, and all the items don't have to be the same type. So they are defined using these brackets here, and pretty much they can contain literally anything. And so each of the items in the list is divided by this comma here. So we see each of these has 3 items. A list can contain no items. It can contain 50 items. It can't contain negative number items. But you can actually access some of this stuff later on. So I'm going to go ahead and pop into my Python window. And I'm just going to go ahead and create some random numbers inside of here. And we can kind of see I have a 3-number list, and I can add on other items to my list. And I can hit enter, and it will return that list. And so that will contain however many items you like. You can even make it 0 items like this as you enter it. So those were numbers. It can contain strings. So we could have A, B, C, D. All right, so make sure to enter one is numbers, try letters. And then the other thing is you can put in mixed types. And I think this is kind of one of the controversial things about Python is you can take your lists and put multiple different types of items in here. So here, I'm going to give you a little bit of an example where I just entered in a list that has a string, a float, and an integer. Other languages can't necessarily do this. It gives you a lot of flexibility. And if you write a large program, possibly a lot of headache. But it's a feature of Python. All right, so I would like you guys to each try putting in a number list. Try creating a number list, a letter list, and then try putting in a mixed list of some kind. And I'm going to give you guys a minute to try and create those 3 different lists in your Python code.
Can I ask a question real quick?
Oh, by all means, by all means.
So I made a list that was like a string, and so I put the text in quotes, and when it's printing with the text still in quotes.
All right. Could you do a screen share or post your code to the chat so I can see exactly what you're talking about?
Well, it looks kind of a mess. Sorry, I've just been typing away over here. Stop. Okay. It's not even showing my screen. Okay. Sorry, I'm on my phone. If I can figure out how to flip my view. I don't know where that option is. Ah, there we go. Okay, as you can see.
I cannot remotely see that.
Oh, you can't?
I will stop my screen share and maybe I can pop that open a little bit.
Oh, because it's too tiny?
Yeah, I can't read a thing on your screen.
Okay.
You can copy and paste that to the chat, and I can take a look at that.
Okay.
Or you could also do a screenshot and maybe post that, and I think that might work.
Okay, but so it is supposed to print a string without the parentheses, the single or the double parentheses.
Yes, it's supposed to do that with. I think it's supposed to do it with single if it's a string. I'm looking at my behavior here. Let's see if I can maybe get you guys another view of my screen, possibly on. All right. Is everyone able to see my ArcGIS Pro window okay over here? I'm trying to make it so that maybe it shows up a little bigger on your guys' screens.
Yeah, that's good. Thank you.
Yeah. So with your strings, if it's a string-based one, I'm just going to go ahead and maybe use some Maronis here, get some space. So I have one here that is A, B, C, D. I can click enter and notice it's pretty much just the same thing except the quotes have changed from double to single, which I guess it just defaulted to.
So that's normal. That's what it's supposed to return with the single quotes. Okay.
Yeah. So that's the string. All right. And is everyone? I want to give you guys another minute to try out the mixed types. Try and do something with a string, a float, and an integer. All right. So does everyone look like they're comfortable with managing at least to get the mixed types to work? All right. All right. If you get rid of your thumbs up, and is anyone uncomfortable? Anyone? Okay.
I have a question.
Yeah. Go ahead.
I decided to try to multiply, so I did 2 asterisks 2, and it returned 4. So if you have a list, so you could actually use a list to calculate also.
There is list math, but that is not something I was going to cover here. That is not a very typical use, I think.
Okay, I just tried it and it worked, but so that's probably something that I should do somewhere else, not in under list. Okay, thanks.
Yeah. I think. Yeah, I think I've maybe toyed with that before, but I've never used that type of functionality ever for a project. So what you're talking about there when trying to perform math on a list is what is called matrix math. And so there, if that is something you are very interested in doing, there's a module out there called NumPy that extends Python, and it is like the bee's knees. It is the best thing if you ever want to do matrix math, where you're multiplying spreadsheets times spreadsheets. But I think for most of your work here, that may not necessarily be the best tool. All right. Does anyone have any other questions?
I have one.
Yeah, go ahead.
When you were talking about floats, you said they're not equal to something. I just missed what you were saying about it.
I'm sorry, I'm having a hard time hearing you over there.
Oh, sorry. When you were talking about floats types, you said that they were not equal to or equivalent to something.
Yes. So, so in ArcMap, I know we have our own data. So if you, I'm just going to pop open an example case on screen here. You can see that, okay? So let's say I've got a points data set. Well, this isn't the best example. All right. So, for instance, this one, I have an FID here. Well, that's not the best example, but yeah, I'll pick up Arnold. So when you have some number fields in ArcMap, they behave a little bit differently. So, for instance, I have this field here in my Arnold data set. I know maybe you guys have vaguely heard of that for RDOT. But for instance, that's a double. I believe there may be a double type for Python, but I think there's other types in ArcMap that may be integers, and I think there is a float type in Pro as well as ArcMap, and they don't exactly behave the same. So, for instance, if you're looking at the precision they have, or the maximum capacity for it, if you have a really large number, those are usually not the same. All right, was that clear as mud, Wanda?
Dirty mud, yes.
All right. I think this really only comes into play when you get to the point where you're reading data from a shapefile programmatically, or if you're pulling from a spreadsheet programmatically, which we won't be doing in this course just because that's more advanced functionality. We're just trying to cover the basics today. But that, yeah, that's kind of how that works. All right. So I'm just going to go ahead and pop back in. Does anyone else have any other questions? All right. So I'm just going to go ahead and continue on with this unit here. All right. So we have one thing that is a Noun type. So Noun types are something that typically you don't create on your own very often. It's kind of equivalent if any of you guys have worked with any database and you had a null field. It's kind of the same thing as that. And so if, let's say, you're reading data or you're doing something, there may be a chance that maybe a Noun type will crop up somewhere. And generally, things start to behave weird. So it's generally good to be aware of it, and it's probably saved my butt a couple times simply trying to test for nulls inside my code for certain things for this Noun type. So why don't we go ahead and I'm going to open up here for my Python window. Yeah, and then I'm just going to type in type none. And bear in mind that none is uppercase N, everything after that is lowercase. So why don't you guys all open up ArcMap and then try and run none over your type function. You should get something that says like class Noun type. I'll give you guys a minute or so to complete that. Thank you, Stephanie. Thank you, Ava. Jackson.
I don't really understand what the point of the Noun type is.
Yeah, so it's not something that you would ever create. It'll come into play if you're working on a project. It crops up. I suppose the most common example would be, let's say if you have a data set and you have a null field and you're reading it and there's literally nothing in it, it's a null. It'll actually come out on the other end as a Python Noun type.
Okay, So basically none is just like representing a null value.
Yes. I think we could probably get into a large discussion about nulls in ArcGIS Pro and SDE, but essentially that's what it does, is it stands in for a null.
Okay.
Because it doesn't really have any null. Python doesn't have anything else that would stand in for a null. One thing that I will end up coming across sometimes is you can actually have a string with no characters in it, and that is different from none. If that makes any sense. I'm sure you've probably encountered this with ArcMap before, where you're searching for something, trying to go like field is null. And then it comes up as being like, oh, there's nothing in here. And then when you do like an equals query and set it to like two double quotes or something, they're like, oh, that works, because there's a difference between something that is null versus something that's an empty string or an empty character set.
So on the pre-direction that you have, object, the first record would return none, and that third record it doesn't have anything in it, so it would probably return as a string, as an empty string.
Yep.
Okay.
Yeah. And I know that if you bring in like if you work with messy Excel data that someone was working on, it's going to have a weird combination of null values, and then you have some strings that will have no characters. You have some where the character is a space. That's one thing that will pop up occasionally as well, is if I can actually create a string that's literally just a bunch of spaces and it's perfectly valid. So Noun Type is really something that helps you with dealing with that wonky data of the real world. All right, is that as clear as mud?
Yes.
Yeah, I think most intro courses don't really put much emphasis on this, but I found when I was learning, it was really disorienting when I was pulling in my own data, and then I was getting these kind of unexpected behavior, and it was because it was a Noun type and not a string. All right, are we ready to move on? All right. Everyone will give me a thumbs up if they're ready to move on. All right, perfect. All right, so why don't we go ahead and, if everyone go ahead and finish out their poll, and I will go ahead and close that out.
On number 4, there's no choice that says we don't have any concepts.
Yeah.
Should we just mark none?
I'm sorry, could you repeat that?
On number 4, it's required, but there's no, we don't have anything we should revisit.
Okay, good. Yeah, then I guess fill out none. Even though that's mostly Noun type, but you're right, that was my oversight. I should have put a no, I'm perfectly good. All right, I'm going to go ahead, and if that's all right with everyone, I'm going to go ahead and close it. All right, let's see how we did here. So Python is a full programming language. So the type of, for number 2, the type of error that occurs when you type in print uppercase P rather than print lowercase p is a syntax error. And then if I created a function that tries to add 1 and 1 together and gets 4, that is a semantic error. So the key thing with a semantic error is that everything functions still. Is that when I initially create it, it doesn't give me flag any syntax errors. When I run it, it completes without crashing. It's just giving me a weird result that I don't like. All right, and I did get one thing as far as number 4 for object-oriented versus procedural. So as far as object-oriented programming goes, when you're learning, you're going to be learning procedural. Don't concern yourself a ton with object-oriented. It gets really abstract. I'd say just with procedural code, the main thing about it is very linear. So it'd be like you have one line, you go to the next line, you go to the next line, you go to the next line. Whereas object-oriented, when you write code for that, it pops around a lot around when you're running it. It doesn't run in a straightforward manner going from line 1 to line 100. It gets more interesting than that. If we do end up doing an advanced course, I could see touching on object-oriented, but just be aware that it exists at this point. All right, it seems like we're doing okay on the how we're feeling about this unit. And this is just supposed to be more or less an exposure course. When you're doing this on your own, the majority of the learning is going to be very solitary. You're writing your own code, debugging it, and you're learning the hard way. But we're gonna get you some basic understanding first. All right. So that is Unit 1. Took a little bit longer than I originally anticipated. So why don't we take a 15-minute break? And let's say we meet back up around like, let's say 9:25. And then we'll go ahead and hit Unit 2 out of 4. Does that sound good to everyone? Give me a thumbs up if you're good with it. All right, I will, the meeting will still be open and we will see you all back at 9:25. All right, so next thing we're going to want to tackle is we're going to deal with ArcGIS notebooks. So ArcGIS notebooks are kind of a beginner's tool that I wish I had when I was learning, that it makes it easier to run code in ArcGIS and save it and revisit it and visualize what the results are very easily. So if you want to make a new notebook, what you need to do is actually pop into ArcMap, and if you select your project folders, you can actually just right click on it and say new notebook, new and then notebook. And you'll pop in and get a notebook. The first time you do it, it might take a little bit, especially if your system's a little bit older. All right, and so you have a nice little interface there. Is everyone able to make a notebook successfully? All right, so in order to make a new notebook, you have to go over to your catalog pane here. It may be hidden, and so you'll have to select it, and then you go ahead and expand your folders. You probably should have some sort of default folder set up in some way, shape, or form. And you can just right click on it, go to new, and say notebook. And that will create a new notebook and open it up. The notebook, depending upon what you're doing in catalog, it may not show up immediately. So you may have to go and right click and refresh your folder. But that's how you create a new notebook. All right, does anyone having any issues with this they'd like to discuss?
Can I close the Python window?
Yes, there should be no problem there.
Okay.
One thing too is the Python window is very different from a notebook. In Notebook, you can save many, many lines of code and run it all at once, whereas with the Python window, you can only run a single line of code at a time. And so the Python window is usually very good when I'm trying to just toy around and understand how, let's say, a particular data type might work. But if I'm doing something more intended for like production use, let's say you've got a project going on, you want to create a program, you probably want to do it in something like notebooks. All right, so that's kind of how you create a notebook. Now, for the first unit, we didn't have to have any class materials because we're just doing everything interactively within the Python window. For this next unit, I have a set of notebooks for each of our units made up for us in advance. And so I am actually going to get this downloaded, just like you guys are about to do. So if you guys remember the box link that was originally sent out, I'm going to go ahead and post it in the chat. What I'd like you to do is go ahead and go to the box link, and I want you to download the intro to Python workshop.zip file. All right, and I'd like you to go ahead and download.
Robert,
You
do you
should
see in the chat? Sorry, this is Tina. Do you see in the chat about the notebook?
Yeah, I should probably send that to everyone. Sorry. Yep, there it is to everyone. Is everyone able to get to the link?
And there's a message about the notebook being created only for that specific project.
Yeah, so this is just a collection of notebooks and a little bit of data. So again, sorry about that. I didn't share the link. You can just click on it and you can go on the ellipses at the end and download. And if on your internet speed, it might take faster or shorter time.
We're supposed to download the Intro to Python workshop zip folder.
Yes, ma'am.
Okay.
Yeah, so should get that zip file. And you can unzip that in any particular folder you would like, but some of the later examples in our code will require that you have it, you either modify your paths or put it in a particular folder. So I'm going to stick mine on my C drive. I have a GIS folder and then RDOT. I've already unzipped mine, but I can go through it again for you guys. Go ahead and pop over a zip file.
Do we have
Yeah.
to sign in or sign up in order to get this to download?
You shouldn't. You should be able to just access it without an account. And when I was downloading it and I won't click download, it gave me a message about logging in, but yeah, you didn't actually have to log in.
Okay, it's
Was
just taking a while, so I wasn't sure if I did something wrong.
No, that you're not. Probably just your internet speed. So I have my zip file. I have 7-zip, but you can use WinZip or whatever other program that you'd like. And I've installed this folder. You can do the same, or you could put it in your own place. Just some of the later examples, if you unzip it somewhere else, won't work as well. In Unit 4, I believe, and the end of Unit 3. So after you've unzipped it, you should be able to pop it right open. And I think when it finally finishes opening up, you'll notice there's a couple different unit folders here. So right now we'll be working out of Unit 2. All right. Has everyone managed to download the zip file?
Mine is still working.
Okay.
Yeah, mine is still downloading as well.
Gotcha. All right.
So can I close the other project that we have open since we're on the RDOT project?
Yeah, by all means, close the old one. This will be an entirely new one.
Can we maybe get this zip file emailed to us? Like, I'm not sure what's going on with this website, but it's not. It usually never takes me this long to download stuff.
Are you using Chrome?
Yeah.
Edge wouldn't work.
Yeah, I do have 2 copies of the municipal boundaries data set in there. That might be slowing things down a little bit. And I think it's a little bit too big to send out as an email.
Okay.
I can give it a shot though. Hey, if would you be as kind as to stick your email in the chat so then I can send it to you?
Mine finally just downloaded.
Okay. Okay, good. All right. Has everyone managed to download? Is there anyone who has not gotten it to download? Please stick a no up there. All right. Has everyone managed to unzip it and open it? Okay. All right. So I think we'll go ahead and start moving forward on this. on our unit here. All right, so we know how to open up notebooks. I think we'll go ahead and create a new notebook just to kind of see how the functionality works. Doing the hello world line we originally started with. So if I go ahead and drop into Unit 2, go New, well, right-click on the folder, and it doesn't have to be this one particular necessarily. Right-click in the context menu, go to New, Notebook. And I'm going to go ahead and stick in the first line we learned, hello world. And so a couple interesting controls here. I can hit run, and then it will actually run the particular cell I'm on. I can run cells in different orders. So I can say, hello GIS, and I can just run that particular line. And I can choose to turn things into markup, which frankly, you guys won't need to deal with, so don't turn that to markup. Or heading, just stick that on code. Should never have to turn that to anything. And we have a bunch of different options in here, so if you wanted to stick a cell between these two code lines, we can actually say insert cell below, or we could tell it to delete our cell by going edit, delete cell. So we kind of have to run everything one cell at a time. If we want to run everything all at once, run all below. But for the majority of the stuff we'll be doing here, it's all just going to be within a single cell. So that's kind of what the options here look like. There are some options to do documentation inside of these for other people to understand. Won't really go over that today. We'll just go over how to run some code, just simply to make it a little bit easier for exercises here. All right, has everyone gotten a chance to open up a notebook and stick in a couple of lines for hello world? Okay. Does anyone need any more time? All right, so I'm going to go ahead and move on to the next thing. So again, you have multiple cells. You can do all sorts of lines inside them. So now we're going to get into the very important bit of variable assignment. So it's nice that we are able to create some data here and there on a single line, but sometimes we kind of want to store it somewhere and use it multiple times in different contexts. So this is where Python variables come into play. So it's something you're really going to need to use a lot of if you're going to make any geoprocessing scripts. So the general convention is you have the variable name, an equal sign, and then whatever the value is. So previously we did hello world. We can go ahead and store that in a variable. And frankly, the variable name really doesn't matter that much. You can call it any number of things, but the name it has to meet certain criteria in order for Python not to crash. So generally you can start it with any number of characters. They can be letters, they can't be numbers or special characters. You also aren't allowed to put spaces inside of your variable names. They just won't work. But they can contain underscores. So I'm going to go ahead and we're going to run a bit of an example script here showing different ways that you can and mostly cannot create a variable name. So I believe that was to B. So go ahead and open up Notebook Unit 2B variable names under the Unit 2 folder. And I'd like you to go ahead and run the code inside of that. All right, has everyone been able to open their notebook and run some of the code lines? All right, thank you. All right. So when we get into variable names, we can kind of see that with the first cell, cats is a perfectly valid name here. It's all just regular alpha characters. If I try and run it on 99 GISers, that will not work because the variable name begins with this numbers, so that will not work. However, if I change it to JSers 99, it works just fine. Cats will not work. The special characters it just doesn't like with that $ symbol there. So that can be applied to a number of different symbols like caret or and. Similarly here with that hello world, it just doesn't quite function right. So we really need to kind of follow some simple conventions of just starting it with some kind of letter and don't include your spaces, any spaces in it, and avoid those special characters.
Can I ask a question about what is on the left side of like the typing area, what does the IN and then the brackets mean? I noticed the number in the brackets change when you click run.
Yes. So in means your input. So in this example I have up here with cats, with the dollar sign, I have in, which is this first part of the cell, and that sort of is what your input is, what you're handing it, and then everything below it is then your output. And for a bunch of these, they won't have an output, so it won't be anything in there. And the number here is a bit of a order reference. So I think in the background, what it's doing is actually it changes whenever you run it, it assigns it a new line number here. So if I run this again, that should probably turn to 15, because the last one, the highest number that I ran was 14 last time. So say if I run 7 over here, 14 down here, and this will turn over to 16, because that will be the highest number that's been run in this thing.
Okay.
So the reason why this is a case is you may have lines that are dependent on each other. And normally with other types of editors that are not notebooks, that doesn't matter. Here it does. If you have cells that are dependent on values from other cells, things could cause some errors, which I think you might end up seeing a little bit later on. But that, I think that the number in there is intended to kind of help you realize when something errored out, you ran it in the wrong order or something. All right, clear as mud?
Yes.
All right. So we had our little variable practice. Was everyone able to complete their variable practice with notebook 2B, variable names? All right, seems like we're doing pretty good right now. Okay. So I think, why don't we go ahead and work in a new notebook, and what I would like you to do is try and recreate this text here. I want you to save hello world to a variable, and then try and print that variable. Because all the variable is a pointer back to this value that you've stored in it. So I can go ahead and you can create a new notebook, or I'm just going to open up my old one. I'm going to say message equals hello world, print message. So you should see here that hello world prints out. All right, has everyone managed to get to store hello world string to a variable and print it? Can everyone give me a thumbs up if that worked for them? All right. So that's our hello world. So you guys went ahead and used your first variables right there. So you can see how this can be very useful, trying to just avoid copying things all over the place. So we've seen variables. Now let's look at functions. So functions are something you guys have already used in this course. So if you use the print function or the type function, those commands there, those are functions. And so the pattern is you have the function name followed by a parentheses, then parameters, and then a parentheses. And not all functions need to have parameters. Some of them don't take any at all. Some of them take a ton of parameters. But we can actually, I think at one point we'll be creating our own functions instead of just using canned ones. But right now we're going to dive into some more functions that are beyond just a simple type and print. We're going to do the amazing help function. So help doesn't quite work with ArcGIS Notebook so well. So you have to open this in your Python window instead. But if you just go ahead and type in help with your opening and closing parentheses, you will get a bunch of helpful information about the help function. So I'm going to go ahead and do this over here. I'm going to open up a new Python window. If you guys already have one open, that works too. I'm going to just type help. And with beginning and ending parentheses. And enter. One thing to notice is there is an error line here. There are some modules inside of Python in the ArcGIS environment that will cause errors, even though they're not supposed to. It's just set up according to the way that ArcGIS implements Python. All right, so if you guys go ahead and try and enter in help into your Python window. And it's just help with beginning and ending parentheses. And get back to that Python when you go to View, Python window. All right. Has everyone been able to run the help function? Could you give me a thumbs up? All right, looking good, looking good. So we have the help function here, but we have some interesting things here is we can actually run the so if we can run the help function off on other functions and get interesting details about them on how to use them. So if we type in help, parentheses, and put print in the middle, we'll actually get a bunch of directions on how to use the print function. So we go help, print. It'll give you some valuable information on it. So typically the way it'll work is you'll have a description of on top of what the parameters are that you can input into it, and then it'll have a little bit of a description of what the parameters are and what the function is. So why don't you guys go ahead and try and type in help print. All right, has everyone managed to get the help print function working? Give me a thumbs up. All right. So that was fairly straightforward. And then we can actually do the same thing with the type function. And so we can go and do help type. So why don't you guys go ahead and give that a try, running the help function on the type function. And one thing you will notice about it is there's a lot of information here, but none of it is in really plain English. So most of this is useful if you want to dig really deep into it, but that doesn't have anything on there that is hyper useful for actually using the function. So the help function actually pulls on documentation that someone wrote for it. And if the person didn't write good documentation or there is none at all, it won't return anything, or it won't return anything fantastic or useful. But most of the time it's pretty good. All right, has everyone managed to put in help and try and run that on the type function? Can you give me a thumbs up? All right. So next step here, we continue to use that function. We also have a bunch of, there are a number of different built-in functions. So when I say built-in, meaning like you can use it straight out of the box out of Python without using modules. There's a good number of them. I don't use the vast majority of them. The ones that are useful would be length, absolute power, absolute value and to the power of, or you're raising it to the power of something. So why don't we go ahead and pop open unit 2C functions for that particular notebook. And this kind of demonstrates what each of those three functions does. So I'll give you guys a minute to try and run over that function. And please feel free to toy around with some of the values for the arguments of each of those, for the parameters for each of those functions, and see how the result might differ. So we have our three different lines here, or our three different cells with three different functions. So the length function is very useful for finding out the lengths of both lists and strings. So we can find out how many items are in this list. So in this case, we found out there are 5. This can be very useful for things, let's say, like holding feature lists. You might have a features inside of a shapefile, and maybe you store all the values in a particular field, and then you might want to figure out what the count is for that. This is one way to find that out, by using the length function on a list. And I use this a lot. The absolute value function is not quite as useful. It would help if I actually printed the result. Kind of see that you can take the absolute value of a negative number and then make it positive. Similarly, you can raise a number to the power of using the pow function. In this case, I just raised 2 to the power of 2 and got 4. All right, so we have these 3 different new functions we've just gone over. I would like you guys to run the help function off of each of those and see what documentation you can get. All right, so I'm going to go ahead and go through the challenge here. So we'll look for the help length function. It's pretty straightforward. It says returns the number of items in a container. Go help power. That gets interesting. It tells me I have 3 different possible arguments here. And the first 2 are required. And it sort of says what it does. So one thing too, when you see documentation through the help and online, is when it some of these may not be required parameters, and usually those ones will have some kind of default value, and that's how it's shown here, is equals, and then next to the parameter name, and then it'll give the default value. And of course, oh, forgot about absolute value. All right, and that one's pretty straightforward as well. It has one parameter in there and returns the absolute value. All right, so was everyone able to complete the challenge just now? Could you give me a thumbs up? Okay, good. All right, so I was using the help function. Next, we're going to go into something kind of important, and that is typecasting or type conversion. In Python, it's not really typecasting, but that's the language you'll see. That's what you'll hear it called in other programming languages. So sometimes, let's say you might have a field inside of ArcGIS Pro that is it contains numbers, but it's stored as a string. And you need to convert that over in order to perform math on it, to get things like averages and sums. And so you need to convert that over. And so typecasting helps you with that, and type conversion. And so there's a number of different functions that will help you with that piece. So we have str function, which converts things into strings. We have the float function, which converts items into floats, and we have the int function, which converts things into integers. So what I'd like you guys to do is open up Notebook 2D type conversion, and we're going to go ahead and open that up and then run it on each of the cells. I believe each of the cells should contain a conversion example for each different conversion function.
It seems like if I exit out of a notebook without saving it, it just gives me like a little circle by my mouse and it won't let me run any other code in another notebook. Is that a common?
Really?
Yeah, so I've had to exit out of Arc. It won't let me do anything in Arc Pro anymore, and I have to keep exiting out of it. I'm assuming that's the issue that's happening, is that like when I close a notebook, I'm not saving it.
I mean, I think if that's the issue, you can definitely save it because you can always download a copy. I haven't heard of that, but I'm not a heavy user of notebooks.
Okay.
Yeah. Is there any chance does your system not have a ton of RAM?
Yeah, I don't think it does. I've been struggling to run Arc Pro on my laptop.
Yeah, that's probably overall. I'm guessing you might be running low on RAM because I'd assume that may be a cause, but I can't be sure. I'd have to take a deeper look at your system. Because I think for each of these units, it's we're going to be opening a ton of different notebooks. But for type conversion, so for a float, the first example takes a number stored as a string and just goes ahead and converts it into a float. Similarly, we can do the same thing with an integer using the int function, where it just takes it and then pumps it out as an integer. And this part here, you can actually convert your integers into floats as well. So you don't, if you're trying to do a to float conversion, it doesn't have to be a string. It doesn't necessarily have to be an integer. It just has to be able to convert over cleanly. And so the built-in type conversion, it takes care of it for you for the most part. Similarly, you can convert numbers into strings, which I find to be very useful for error messages. Is if you have something that is storing some values, you can output it to the screen as a print statement, and then it is very useful for figuring out what's going wrong. So those are those three different type conversions. So I've got a little bit of a challenge for all of you that we haven't gone over at all. I want you to take a Noun type and try and convert it into a string. And I'd like you to see what value you get. I think you might be a little bit interested in that one. I'll give you guys about a minute to go ahead and try and do that conversion. All right. Could you give me a thumbs up if you were able to try and convert a Noun type into a string? Okay. I have one. Am I getting any other thumbs up? Anyone else were able to complete that? 2. And a bit of a cheat to this is use the str function that we saw earlier. And it should be a little example of string conversion is in the 2D unit. All right, I'm going to go over the solution here. So if I go ahead and go str none, I'm sure all you can see this very well, but we got a interesting result here. You kind of see that when we convert it to a string, it actually is just the text none. Like just none. So if a none type ends up creeping into your code at some point, and then you try and convert it to a string, you can get interesting text in there. So maybe you might end up trying to do some work later and be like, why does this have a bunch of nones in the text? It's kind of where it comes from. All right. Does anyone here need some more clarification about this one? All right. So that was kind of that none type issue. What we're going to do next is we are going to work with creating our own functions. And so we've used functions that are built into Python. But the interesting thing about functions is you can call them many, many times. So it's a very good way of reducing the number of lines of code you have. You can reuse a lot of it multiple times. So the way you define your own custom function is you stick in the keyword def, then the function name, followed by whatever the parameter name is in parentheses, and then this little colon here. And then you indent one step over, and then whatever logic you put in goes after that indent. And then you can call that function later on. So it's a little bit abstract until you actually start doing some of it. So what I'd like you guys to do is open up Unit 2E, Custom Functions, and then once you open that up, I'd like you to go ahead and give that a run. Unit 2E, Custom Functions. I'm going to go ahead and give you guys a minute or so to run that. All right, has everyone been able to run Unit 2E Custom Functions? Could you give me a thumbs up? All right. So I'm going to go ahead and go through this. So we have, in this first example for cell 1, we've got a definite, we have our keyword DEF for the function name. We have the function name and the parentheses are required even though there aren't any parameters for it. And notice this indent here, that you can go ahead and stick an indent, and that helps define what gets run. So you can see that it gets run. It gets run there twice because I called the function twice. See there, like super amazing and super amazing. It didn't go ahead and run the GIS is okay line there because it's not part of the function, because it's not indented. In the second line here, we can kind of see a bit of the use of some parameters here. So I can say, hey, there's a certain number of students in the class. I can hand that off to this function here. So it takes the number of students, takes class name, and it then just outputs a message, stores it as a string, and then prints it to the screen. And so you can kind of see that, all right, I listed these in this order, where the first item was class name and the second one was number of students. Then when I call it, I then just hand off, be like, all right, that's class name as a string. And then there's the number of students as a set of numbers here. And notice how I was able to run it multiple times without changing and duplicating the code. I just had to keep on switching out what the input values are. All right, so that's kind of a little bit of functions in a nutshell. All right, so that was kind of a bit of the functions piece. Now we're going to hit up a little bit on number arithmetic. So just like, normally when you do things on paper, you can add, subtract, divide things. You can do the same thing in ArcGIS Pro using Python. And so what I'd like you to do is go ahead and open Unit 2F, Number Ops. And go ahead and run that through. Give you guys a minute or so to try that out. All right. Could you guys give me a thumbs up if you've managed to run the 2F number ops notebook? So the notebook is pretty straightforward for this one. So we can actually add together numbers. We can subtract. We can also do division. And it's pretty intuitive as far as like plus, minus, divided by. Multiply by is going to be an asterisk. And it also follows order of operations as far as when you use parentheses. So if you ever have any more complicated formulas, you can use your parentheses and get some fairly complex stuff going. All right, I think we struggled a little bit more on functions. So why don't we go ahead and do a little function challenge here. So what I would like you to do is to create a function that adds two different numbers together and then prints the result to the screen. And I'm going to go ahead and give you guys a good 5 minutes to try and get that function going, and then we'll see. I'll go ahead and show you the solution. All right. I think we've gone to that 5 minute mark. Could you guys give me a thumbs up if you succeeded when meeting the challenge? Okay. Oh, all right. Seems like we got a little bit more success than I was anticipating here. So for those of you that got stuck here, I'm going to go ahead and go through a challenge solution here, which, surprise, it was I got a challenge solutions inside of here. So adding two numbers together as a function. So here we are here. We have we define something here. We define the function. We call it add. You could name it whatever you want. I'm just saying var1 and var2. Just going to go ahead and add the two together, save it to a variable called result, and I'm then going to print the result variable. So when I go ahead and run the function, I can then get the result of 2. All right. We're pretty good with the challenges. So next thing is string concatenation.
Wait, can you go back to that example just for a few more seconds?
Oh, yeah, by all means, please stop me.
So you don't have
All
to
right.
ask it to print the result of the definition. You just type in the values in the defined function.
Could you repeat that? Because
like, I guess I thought that you had to, after you had the add and the parentheses, that you then also had to click, like, type in print, but I see. You don't have to. It's easier.
well, this one, the print is part of the function. Do you see how in my code it's indented with the rest of the function?
Yes.
So I could change this around a little bit differently, and I can use print outside of it, but because it's part of it, I don't have to. So if I was to reformat this so the print was outside of the function, I could then go return result. I suppose I didn't go over this part. And then I can go result equals this. And then I can go print result.
Okay, but that way is one more line of code. So the way you did it before is, I guess, more efficient.
Yeah, well, and I mean, you'll find a lot of programmers that will talk a lot about efficiency, but at the end of the day, it's a matter of like, did you get the job done? Is it a nightmare to maintain? That's kind of what it boils down to. So if your solutions are very dirty, I'm cool with it. I think the only time that becomes a little bit difficult is when you have hundreds of lines. Then it starts to become an issue, but you can be as inefficient as you'd like.
Okay, thank you for that permission. I'll tell my boss that.
Yeah. Yeah. Granted, sometimes it can get, I can probably jump to this one. So if, could you give me a thumbs up, if any of you have used OpenStax before for finding answers to things? Okay, so no one's heard of OpenStax. So OpenStax is a programming question and answer platform. OpenStax is normally geared to programmers, but there is a GIS OpenStack out there as well. Some of you may have used it without realizing it. Oh yeah, Stack Exchange. Thank you, Stephanie. Stack Exchange. And you'll find on that there'll be people that will post solutions that are 50 or 200 lines long. Scroll down toward the bottom and you'll find someone who puts in a one-liner. For some reason, people don't like the one-liners. They like the complicated bits. So keep that in mind as well. Is that when you're looking at answers online, the more lines it is doesn't mean it's better. All right. So is everyone okay with the challenge contents, or do we want to discuss that a little bit more? Give me a thumbs up if you want to move on to string concatenation. Okay. All right. Does anyone have any questions they'd like to bring up about the function challenge? Any more questions? Okay. So string concatenation. So this is something that I probably use in the vast majority of the programs that I write. And that's, so we've seen that you can do arithmetic with numbers. You can do the same, you can do a little bit of arithmetic with strings. So you can actually add strings together and then they will equal out to what the combined piece would be. So I find this very useful for writing debugging statements and print statements. And it also is very good for constructing file paths. If you're writing any scripts that involve like trying to combine a folder name with with the particular file name you want to call it, this is very useful. So if we go ahead and, in the example here, we have a variable. We can define many of them, and we just literally add them together, and then we then get the combined text. The only problem with this is sometimes I forget to include spaces, but this is a fairly easy way to deal with this. So we have an example in Notebook C1. I believe I might have the number off on that. No, it's G2. I apologize for that. It's G2. I'm reordering some of these ones. G2. Please go ahead and open up Notebook G2, string concat, and go ahead and run through those examples. I'll go ahead and give you guys a good 2 minutes to go ahead and run through that, and then try and toy with it a little bit on your own. All right. So I'm guessing all you guys have completed that that G2 notebook. So we run through this. This is the first example that I showed you in the slides, just assigning variables, and then go ahead and just combining them, and you get a final result here. But the second one is the most common example I think you guys will see in your work if you're doing any projects, is you'd be like, all right, I know let's say you had some code earlier to find out how many shapefiles there were. And you're using this as a check to make sure the script is working right. You can say, okay, I'm going to construct a string that says number of shapefiles equals however many, and then be like, you know what, there's 75, but I know there's 100, so there's something wrong with the script. And so I think this will be probably the way you guys would be using concatenation a lot of the time. All right, is everyone feeling okay about the concept of concatenation here for string concats? Give me a thumbs up.
I wanted to mention something on concatenation because this got me the first time I tried to do any concatenating. Is I had 3 fields that I wanted to string together and create a new field. And one of those fields was a number. So I had to make sure I took that and I converted it to a string before I could concatenate it.
Yes, I'd say you're exactly right with that. And one of the things to keep in mind too when converting to a string, especially if the field you're trying to combine to, it is a number you're trying to add to the string. You may need it formatted in a particular way. So by default, one thing that happens when you say number shapefiles is one example. We change this to 75, change this to a string, but if, let's say this was a decimal, one thing that can end up happening is you may end up with a lot more decimal places than you anticipated, because it will stick everything in there for your decimal places, and maybe for your purposes, you might want it formatted with let's say if this was over 1,000, you might want to put commas in it and such. And so there are formatting related tools within Python for that. That's out of scope for today, but just realize that those are options if you needed to output something as, let's say, dollars with commas, or you needed to round to a specific number of decimal places. You can definitely do that. You just Google around, find something on Stack Exchange to get you in that direction. But thank you so much for that good point there, as I've definitely run into that too. Does anyone else have any comments, questions, concerns about string concatenation? All right. So I'm going to go ahead and have you guys tackle a small challenge. So what I'd like you to do is to create a status variable and go ahead and set that to value running. Print that variable with some kind of descriptive message, and then go ahead and change the status to complete and print that the descriptive message. All right, those instructions look okay to everyone? Go ahead and tackle that challenge. All right, I think we've met time on this one. So, how many of you guys completed the challenge? Give me a thumbs up. All right. Let's go ahead and go through the solution here, because I'm sure there's more than one way to get this completed. Which challenge was this one? Program status. So here's the way I implemented it. I went ahead and created a status variable, set it to running, and then I went and said print, and I just concatenate it with the program status. And then I went and reset the status variable to complete, and then printed the program status again. And as you can see, I can see all of the different lines printed to the command here. And if I was to write a larger program, I could stick all of my code in here, and then I'd be able to tell if it's stuck or if it's running and completed, because that sometimes can happen. So the useful thing is to stick these in multiple pieces of your code to track status. So it may be that you get stuck in an infinite loop, or something's taking really long, and doing this kind of status checking can kind of help you troubleshoot where the problem might be. All right, so that is our challenge. And then I'm going to go ahead and launch our poll for Unit 2. So if you guys could go ahead and fill out the poll for Unit 2, and let us know how we did here. You should be able to see one pop up on screen right now. I'll give you guys a minute or so to fill that out.
And number one has the same issue that we don't have an option to say everything's good. So I'm just gonna click ArcGIS notebooks. I don't know what else, or what do you want me to
Okay,
click?
okay, that's fair. All right, yeah, we'll make sure that's the case for the future. All right, and does anyone would actually like me to go over functions again?
Personally, I feel like I got a little lost on the functions.
Okay.
I don't know. I was able to write one earlier.
Gotcha. All right. Well, the materials will be available online, and we can just go ahead and go through it again here, but my explanations aren't helping. There are a lot of resources out there because my explanation might not ring true with you. All right. So the idea with a function is you have, are you comfortable with how to call a function in the first place, right?
Yeah, for sure. I guess I'm not exactly sure where I thought I was confused. I think just
No,
in like the
that's okay.
syntax, like
That's
some of
okay.
them have colons after the first line and others don't.
So when it comes to functions, I suppose I maybe didn't draw a ton of attention to this. Functions with the first line saying what the function name is will always have a colon behind it on that first line. And so if we go into Unit E2, that this can have as many lines as possible behind it. So we could print different stuff here. So maybe a thing that I probably didn't pull a ton of attention to is the parameter names. So if we start here with me calling other amazing thing, I have first parameter, and that goes into class name. And then I have a parentheses, that's the second parameter, and that goes into number of students. And so the first line will always have define, function name, parentheses, with the with each of the parameters in it, which just like this one up here, it might have none. And then it has this colon here. And so each of these values that I created on other amazing thing, when I called it, get passed on here, and I can use them in the function.
Right. And I sort of understand that. I think I just am not great at the syntax part yet. So when I was trying to do this earlier.
Here's one thing. Did you how did you indent when you tried to create it? Did you
I used tab.
Okay, good. Tab works because Now, one problem that I'll have and other people have is if you mix tabs and spaces or 3 spaces with 4, it doesn't like that.
Okay.
All right, sorry, I don't know quite how to explain that a little bit better. My recommendation is maybe after this course, there's a lot of free textbooks. Go ahead and look at a chapter on functions for Python, and you'll probably get a different perspective on it than what I could give you here.
Okay.
Yeah, but you got the at least the rough exposure.
For sure. Yes.
All right. All right. Seems like we're doing decent right now as far as our understanding at this point. So we'll go ahead and end that poll. And we are now at the end of our second unit. So I'm going to go ahead and say we'll take another 15-minute break, and we will meet back up at, say, like 11:25 about, and then I did have 2 more units. I don't think we'll be able to fit both of them in, so I think I'll do a little bit of a smattering of both, just to give you guys some exposure. All right, so everyone's cool with that. We'll go ahead and see you guys at 11:25. All right, so let's go ahead and start this up. Can everyone see this YouTube video I have pulled up? Give me a thumbs up if you can. All right. So this, I thought I'd go ahead and jump into a little bit of utility, because I think we've been spending a lot of time with the basics of the basics, and sometimes you just need a little bit of an idea of what you're aiming for. So this is something I wrote a while back. It was a bit of a dead-end project, but this is doing some cartography automation using some Python toolboxes. And so some of the stuff is fairly simple, things you could possibly do with a map series. You're like, oh yeah, I can zoom it to the particular area. But this one actually applies a bunch of different rules conditionally based on what particular zoom levels you want. Zoom breaks, I'm not sure if map series will have this, but you can put some pretty complex rules on your zoom levels.
I was let into the room late. Can you give me like a really quick update as to what we're looking at?
We're only 25 seconds in, so I can start from the beginning for you. Yeah, so this is a script that I wrote that was a bit of a dead-end project. This is kind of what you might be aiming for, seeing what the potential is for what you could automate. And I've done this probably with 2 different employers, where I'm sure most of you have done like data-driven maps using like a map series or Atlas, I guess now it's called. But an Atlas doesn't really address concerns if you're trying to produce like 4 different types of maps for the same area. And that's where automation come in to help, because if you have really fast turnarounds you need to meet, or if you're making the same map 50 times a day, all right, you've made your templates for it, but that has limits. So what this guy does is I wrote a bunch of Python toolboxes that do different functionality, and not all of it's actually kind of functioning at this exact moment. It functioned at one point. But you know, you can zoom in data-driven pages, but you can decide which particular breaks you'd like to make for different rule sets for what you want to zoom to. or what do you want to expand that zoom level out to. And I got some other ones in there for something that you guys might be very interested in is putting in dynamic tables. This was kind of labor intensive to set up, but basically, if you notice there, it just generated a table down here and then populated with all values driven by the actual underlying database. I know there's some functionality you can get out of data-driven pages for this, but not when you want very specific placement of text in particular formatting, like it just lets you do a traditional table, and this is not a traditional table. It's broken out into like sub-columns and merged columns. And that matches the taste of what our leadership has, wants. And then this last one, I believe, is the most time intensive, but it's no. See how it changed the county up there? So I can actually change that based upon what it's located in, which I think you can do with data-driven pages, but you can't do multiple counties. This will do that. And then I know it doesn't quite show it very well, but actually we'll readjust the legend according to particular items that are in it. It'll actually remove them and only show the items that are relevant. And then one thing toward the end that I fast forwarded through, I'm not sure if you caught that, but I had labels all across here and then just repositioned all of them and then moved them to each of the corners there, directly next to the different row state highways going outside of the extent. And it actually labeled each of these according to what highway it junctions with, possibly 50 miles down the road, or what city it terminates to. And I did a bunch of work where it ties in dynamically to the feature service from the state GIS office, and it ties into dynamic roadway data. So it'll generate new results every time something is changed, if you run it. And so that, because our leadership particularly likes this style where you have a label pointing with an arrow pointing out down toward the location and labeled according to that adjoining city or junction. And so these are functionalities that would be incredibly difficult to replicate with any built-in functionality. And so you can customize this to a heavy degree. I recommend this if you have a maps type or set that has a very defined expectation from your end users to be like, it always looks like this. I need it to look like this. And if you're doing a lot of them, it makes a lot of sense to automate something where it could populate everything for you, and then all you're doing is some slight adjustments. I know one prime example, when I was an intern, remember a real estate company, they had maps that they generated, and they managed to cut down map generation to a half hour using templates. Using automation, we're able to cut down that map generation time from 30 minutes to 10. So if you have something that is very time dependent that you're doing a lot of and the product is regular, you can use Python to tweak everything according to the particular tastes and expectations of your end users so that it does most of the work for you. And then all you're doing in the back end is tweaking some zoom levels, colors a little bit, and then it takes care of most of the rest of it for you. So just thought that's kind of what potentially be aiming for. It's all possible with the ArcGIS interface. with the Python API. So since it's a little bit shorter, I'm going to try and get through file paths, and then probably cut it off after that. So we have something called objects. I think I alluded to this at the beginning, where we had, like there's object-oriented programming, procedural programming. So everything I'm doing thus far is all procedural, and you won't be doing any object-oriented anytime soon. But you do have to work with objects. So the majority of functionality that you get from interacting with ArcPy and the Python interface in ArcGIS Pro, you have to deal with their objects that are predefined. And so you need to interact with those. So let's try and understand what objects are without getting too deep into it. So we got experience with both functions and variables, but objects kind of combine the two. A kind of a collection of functions and variables, but they change the names around. So rather than calling it a function, they call it a method. And rather than calling it a variable, they call it a property. And it's all just sitting in under the collection, the main source for the object. So a bunch of the analogies that you'll find if you look it up is, hey, an object is like a chair. It can have various properties, like it can be black, it can be a Romanian chair for its style, it can be 100 feet tall for its size, and so you have this various attributes. But then you might also have actions you perform to it. So you may have maybe it's a folding chair, and so it has an action called fold, where you fold it up. And so the idea is that these properties are essentially variables, and the methods like folding are just like a function. It's not exactly, but I think for your purpose at this point, they're the same. And the way you access them when you look at an object is the same. So you have the object name, and you have a dot, and then you have the method or property. It works the same way for both in order to access it. Some of this is very, very abstract. So why don't we get into something hyper practical then, based off of dot notation. So lists are kind of the bread and butter for Python, but we've just defined lists. We really haven't interacted with them. So what I would like to do is go ahead and introduce you to some methods that a list object will have, because surprise, all of the data types we've been dealing with, when you've been interacting with them, they're actually objects. So a list object contains a lot of different functions, a lot of different methods, but the ones that are most useful, I find, are sort, pop, and append. And those are just things that help add and remove items and change their order. So what does that look like? All right, well, I'd like you guys to open up Unit 2A, List Methods notebook, and I'd like you to go ahead and run the various examples inside this notebook, and you can see how functions are used in how these methods are used in the wild. All right, so I'll give you guys, say, a good 3 minutes, and then we'll go ahead and talk about what those functions, what those methods do, and why they're functional the way they are. All right, I think you guys have been given a little bit of time to run through this this notebook, and so what do each of these mean? Right, so we have a simple variable here. We have a list, and it's pretty straightforward, just has a bunch of numbers in it. Then we apply a method to it. So the method is going example list dot sort. So you're listing out here the object dot method name. And sort doesn't have to take any parameters at all, so there's nothing there. They're optional. And you'll notice that, hey, after you've run the sort method on your list, it will reorder the items in it. And that is something I use very often to make those fit in a particular way for what I'm looking at. And there are custom ways to sort, not just that way, but that gets into kind of the more detailed parameters for sort. Pop is also equally useful. So the naming of this is not remotely intuitive, but so you go example.pop, and pop takes off the very last item in the list. Whatever that last item is, it just removes it. And then append is something, probably the method I use the most on the list object. And all it does is it adds additional items to your list. So we can see here, we take the text, the string here, GIS is great, and it just adds it on as the very last item in the list. All right, so that's kind of basics of that. So what I would like you guys to do is a challenge now. I would like you to create a list of GIS data sets that you like, and then I'd like you to then sort them using this sort method. Because it is a method, because I keep on using those interchangeably. All right, why don't I give you guys a good 4 minutes, and then we'll go ahead and go over the answer to that. All right, so why don't we go ahead and go through the answers to this one. So for sorting, here's the solution. So I have a nice list of data sets over here, address points and parcels and lakes. Notice how they're kind of out of alphabetical order. When I head and run, I see data set list dot sort with the open and close parentheses. And then I go ahead and I'm printing it to confirm the results. And you can see that the order has changed. All right, so that is that one. I think we're running a little bit short on time to go over file paths, because that's probably one of the more useful things here dealing with. How about we jump to learning resources with our remaining time today. So there are a lot of learning resources out there. So you have the standard documentation here coming from the project for Python 3. And this one here contains just a list of all of the built-in functions. But surprise, you don't really need to know the vast majority of them. It's only a handful that I use on a regular basis. Stack Overflow. If you search any particular questions you have, chances are there will be a Google result where someone has asked it before on OpenStax. Maybe not your exact question, but one that's really close. If you are someone who has learned another programming language before, your first language is your hardest one. They do have, so this is Learn Python the Hard Way. One thing you'll find with programming is usually there is a version of a learning textbook called The Hard Way that just skips a lot of the basics that you pick up the first time you learn a programming language. If you haven't learned one before, I recommend not using it. I think it might be a good resource if you've hit up a couple before it. If you want to do anything with Esri, they have extensive documentation down from tutorials to breakdowns and examples. You'll find no lack on Esri's site for ArcPy, as well as you do have Code Academy, and there are other sources like that out there. But I would also caution you against learning Python entirely through a web service like Code Academy. So the thing that Code Academy does well is it teaches you the basics very well of like, oh, how do these different variables work? But the minute you get into anything practical, the utility drops off. All their stuff is, for these types of services, will be written in a way that is system agnostic and isn't tied into any useful modules. So you really need to just bear in mind, all right, maybe you've gone through a Code Academy course for Python, you feel pretty good about it. Do projects. That's you've just gotten through the first trials of getting some basics down, but you need to code more in the real world. So best advice for getting better at using Python: do more and more projects. There's not really getting any way around that. So I know with this we've gone ahead and ran some examples. I've put out some challenges for you to write some of your own stuff. So the more you write, the better you're going to get at it. There's just some stuff that you just can't learn out of a textbook. You need to try it. But don't ever just learn Python to learn Python. Always have a project in mind, and that's always a motivating factor. Helps focus what you need to do with it, because if you're just learning a programming language to learn a programming language, that isn't going to do you any good. And one thing, when I taught myself Python in college, entirely out on my own outside of any classes, and what I found was very useful is there are dozens and dozens of free books on Python and freeware courses. And so generally you find one textbook that is kind of your rock, and then work through it one unit at a time. If you're stuck on something like functions or object-oriented design or variables, be like, I don't understand it in here. It doesn't explain it that well to me. Jump books. Go to the same chapter in another book or another course, and they usually have very different ways of explaining things, and maybe that might jive with you much better. And I would caution you, I know you probably have some particular thing you really want to do, and maybe you want to jump right into the Esri documentation and learn something on how to just copy and paste that code over, modify it, slowly get it working. But time and time again, I fell into this trap when I was first learning, where the first textbook I picked up was an Esri book. But when you jump right into that, you don't really understand the programming language. And I was floundering around, and eventually I had to just go back to a introductory computer science textbook. And most of the time when I get stuck on a programming problem, it's not due to lack of trying, it's due to a lack of understanding. So it's something about maybe the modules or the data types that I'm using that I just don't know how to use correctly, and there's something that I have a misunderstanding about. And so generally, if you're stuck and you keep on trying, you're still stuck, go back to the documentation, go back to examples and coursework and be like, oh yeah, I totally misunderstood how that worked. And again, the only way to get better is code, code, code. So one thing that I hope you get from this, I believe Stephanie brought up a number of different about modules. So I don't have that in here, but I can tell you which ones I've used that are hyper useful. So Python CSV module. We really didn't get time to go into modules. I had one for the file types unit, the file paths. But CSV is a very good module for reading and writing CSV files and tab files and other documents like that. ArcPy, obviously, for ArcMap. And then we also have, if you're doing data science work, you want to look at NumPy. NumPy is kind of complicated, and I wouldn't advise going into it for just anything. If you do anything raster-based, if you're doing raster analysis for one thing or another, there's ArcPython things that will convert your Python, your raster into a NumPy array, and that opens up all sorts of possibilities on interesting customized calculations you can do on it. If you're doing data science work as well, there's PySci, I believe, a SciPy that is for data science work, and then probably one that is very underrated is the OS module in Python. It is an interesting one that deals largely with messing around with basics of moving around with within file structures. And their file path submodule is really good for messing around, merging, and manipulating file paths. There's a lot more out there. That's the ones that I found the most use from. But if you're just Google around, I think you'll start to find different modules and kind of scope them out before you try to invest a lot of time in learning them. But thank you guys for joining us today. You're all a great pleasure, fantastic students, and I hope to see you guys again at the next Users Forum event in person that we can have.